Unit 1, Periodicity. We have done some homework last time. I think all of you can remember that you had already prepared periodic table booklets about the periodic table and the history of the periodic table and the periodic properties. Anyhow, today I am going to explain in briefly what are the periodic properties and the details about the periodic table. So if you are considering about the history, I'll just give some details to memorize it, right? So very beginning, very earliest time, Perera gave some classification method, the element classification method. So that classification method was triads. His method was triads. Triads means he told there are three elements which are always showing the same kind of characteristic features. So we'll take one example. Lithium, sodium, potassium. He told that if we take the mass number of lithium and the mass number of the potassium and add those two masses and divide it by 2, always very similar to the mass of the sodium. So we label that as the triad. But actually nowadays, you know, it is not a very good classification. Anyhow, that was the first classification of the periodic table. Then the most important classification was explained by the Newland's classification of elements. Newland's classification, he explained it as the octave of the music. So I think you can remember the musical octave. There are 7 notes. After 7 notes, again the 8th one is very similar to the first note. So he told like that, but most of the scientists at that time, they laughed at him because it was not work. But his idea was the brilliant, and they used it later on because he gave the idea about the periodicity. At the beginning, very first time, the scientists didn't have the idea of the periodicity. But after the Newland's idea, he gave the periodic properties or the periodicity of the elements. Then later on, he won the Nobel Prize after his death. Beforehand, they didn't identify what was the actual importance of his idea. But afterwards, this is the first one, this is the second one, and the third one. Intermediate things are there, but we are not going to discuss that. Mendeleev's classification of elements. Mendeleev's classification also based on the mass number of the elements. But some places he himself did it in the other way. Sometimes actually he categorized it according to the increasing order of the mass number. But some places he realized it is not accurate, therefore he put some element in the other way around. But he couldn't explain why he put it in that manner. Afterwards, other scientists, after himself, the other chemists identified his classification was very accurate. Instead of that telling it other way also, because he always according to the increasing order, but increasing of order of the mass number, but he has already overcome his that idea and put it in the other way round. Right. Then afterwards, fourth one, after the Mendeleev, Henry Moseley gave the next idea about the classification of elements. That was based on the property of atomic number. He told that fundamental property is the atomic number of that elements, not the mass number. Therefore, nowadays also we are using this atomic number classification, because increasing number of, when we classify the elements according to the increasing number, always after 8 elements, again the 9th element shows the same property of the first element. So it is the periodicity. We can see the same property again and again. That one is the periodicity. So Henry Moseley's idea was the most important part. But when we compare this with the Mendeleev, Mendeleev also categorized these elements according to the mass number, but he had categorized it very accurately by considering about the properties of the element. Therefore, the honor goes to the Mendeleev because of the finding of this new periodic table. But it was modified by the Moseley. Then afterwards, the long form of the periodic table also we can see. So let's look at the periodic table. Can you see? Right. Then if you see the, look at the periodic table, you can see here there are 18 groups. 18 groups. Right? This is the first period, second period, third, fourth, fifth, like that. There are 10 periods. After that, this one is 13, 14, 15, 16, 17, 18. 18, it is given as 0 also. But there are number of classification methods of the periodic table. But nowadays we are using the IUPAC nomenclature or the IUPAC numbering of the periodic table. So I like to tell you what is IUPAC. Right, UPAC. International Union of Pure and Applied Chemistry. So they already accepted, all the chemistry things are accepted by the IUPAC, and then they distribute it throughout the world. So this is the world recognized authority. Therefore, they have labeled this periodic table from 1 to 18 groups. Earlier British explanation of the British numbering was 1A, 2A and 3A, 4A, like that, up to 7 and then up 0. But nowadays we are not using the A level because IUPAC classification is from 1 to 18. So another special case, they have divided it into 4 groups, main 4 blocks mainly. Group 1 and 2 is S block. Group 1 and 2 S block. Simple S block. It is group 1 and 2. Then group 13 to group 18. Group 13 to group 18 categorized as P block. Then intermediate from group 3 to group 12. Group 3 to group 12 is D block. Then this separate part, I think you can see this separate part is F block. But F block is not in our syllabus. F block containing with lanthanides and actinides. Lanthanides and actinides. But F block is not in our syllabus. We are going to learn S block, P block and D block. We'll see what are the common characteristic features of S block at the beginning. Now we see the common features of S block elements. Right. Then I told you group 1 elements and group 2 elements belongs to the S block. So by taking your previous knowledge or memorizing about your previous knowledge, you know group 1 elements, they have only one electron in the outermost energy level. So what is the electronic configuration? Common electronic configuration of the group 1 elements, NS1. Common electronic configuration of the group 2 element, NS2. So S block always categorized according to the entering of the last electron to the S orbital. Now you can see it. All these two groups are S block elements belonging to the last electron enters to the S orbital. Okay. Then according to this, there are certain characteristic features arises, that their reactivity, their size of the atom, all are depending on this electronic configuration. We'll discuss it one by one later in the periodicity section. Right. Then if we take the second one, P block. Right. Their P block elements, always we categorize the elements into P block according to the filling up of the last electron to the P orbital. P orbital. So if you take P orbital, the maximum number of electrons that can be filled to the P orbital is 6. Therefore, it can vary from P1 to P6. 1, 2, 3, 4, 5, 6. So 6 electrons maximally can keep by the P orbital. Therefore, 6 groups we can talk about in P block, as you see in the periodic table. This is the P block, right? It starts from group 13 to group 18. Then if we take the P block elements, most of them are also metals, but non-metals, liquids, right, gases, all are there. But if you consider the S block elements, all are metals. All are metals. That is the speciality. But P block, it is a combination. Most of them are metals, but liquids are there, gases are there. Right? Solids, liquids, gases, all the things are including in P block. Then if you come to the D block, all elements are metals. All elements are metals, right? So the common electronic configuration, if we write it, it always N S 1 to 2, N minus 1, D 1 to 10. So what is this? The D block elements always, if we take the simple example, electronic configurations 3D and 4S. So it is like this, 4S sometimes the 1 electron in the 4s orbital, sometimes 2 electrons. Similarly, previous penultimate shell d orbital is there. Therefore, we can write it as n minus 1 d 1 to 10. 1 to 10 means 1 electron to 10 electrons can be filled. So, all these including in the group 3 to 12. Group 3 to 12. Okay. Then these are all about the periodic table of the elements. Then now you have learned about the periods. So I told these are periods. So how many periods there? 18. 18 periods. So similarly, this side, the horizontal lines are labeled as the periods. Right? Then how many periods? We encounter 7 periods. Right? 7 periods. The first period is a very short one with hydrogen and helium. Hydrogen and helium actually not showing the very much similar properties to the group 1 and the group 8. But most of the properties are equal to group 1 and group 8. But some properties are different. Therefore, what they have done, it has taken as a separate period. Separate period. If the question is asked what is the shortest period we have in the periodic table of element, is the first period. Then the second and third periods are also with shorter periods because they have only 8 elements. Then after going to the period 4, it is a very long period with the 18 elements. With 18 elements. Then afterwards, all periods are with 18 elements. Right? We are not including this inside to this or embed this F block inside to this because it is not in our syllabus. Then it will be more complicated. Right? So, what are the things that you have to memorize? The shortest period is period 1. Then another somewhat shorter 2 periods. What are they? Period 2 and period 3. Then afterwards, from period 4 onwards, all are long periods. There are 18 elements in all that periods. So those are the main idea about the periodic table. So we have to discuss it one by one. Right. You can take more details from your resource book, page number 30, 31 and 32. Please refer the resource book, page number 30, 31 and 32. Okay. Right. Then we'll take the periodic trends shown by S and P blocks. Okay. Then mainly in the periodicity that certain sizes and reactivities and certain properties are changing according to the situation of that element in the periodic table. So we can classify those things according to their properties also. So very simply, before talking about the periodic properties, you should know this part. Right? If you take the nucleus and the atom that with the electrons, now you know that electrons are moving in the certain orbitals. Right? You have learned Sommerfield's quantum numbers. According to that quantum numbers, you know where the electrons are situated and how their motions and all. So these electrons, anyhow, these electrons are moving around the nucleus. In the nucleus, neutrons and protons. Right. Protons are positively charged particles. Neutrons are neutral. electrons are negatively charged particles. Then definitely when they are in this kind of structure, the protons and the electrons, they are positive and negative charges or unlike charges, therefore they are attracting with each other. There is an attraction between the electrons and protons. Similarly, if the electrons are negatively charged particles or they are like particles, right, they are like particles, then definitely they have the repulsive ability, they have repulsion. So all these are balancing inside this atom, So if we consider the outermost energy level of the atom, that electrons always also attracted towards the nucleus, but that attraction is somehow covered by the innermost electrons, right? The attraction of the final electrons to the nucleus is always that actually acting as a barrier, right? Acting as a barrier, the innermost electrons, right? So actual attraction or the feeling attraction to the outermost electron is getting less because of that reason. Or very simply, we can explain that the attraction between the nucleus and the outermost energy level electrons are covered by the innermost electrons. So that effect is labeled as the shielding effect. Shielding effect. Right? Shielding effect. So it is acting as a shield. Therefore, the amount of the attraction felt by the outermost electrons are getting lower because of this shielding effect. Right? So that attraction is labeled as Z effect. Right? That according to this shielding effect, actual attraction is not felt by the outermost energy level electrons. So actual one is taken as Z. So always actual attraction is greater than the feeling effect. Because of this shielding effect of the electrons in the innermost energy levels to the outermost energy level, right? So that is the shielding effect. Okay. Then because of that, there's a amount of charge that can felt by the outermost electrons, that is labeled as the effective nuclear charge. Effective nuclear charge. Right. Then that always the effective nuclear charge is lesser than the actual nuclear charge, because always the shielding is done by the innermost electrons. Okay, that is the main idea, and this relates with the size of the atom and their reactivities and the ionization, right? And their radii, or everything depending on this shielding effect and the effective nuclear charge. Therefore, you should have a clear idea about these two. Right. Then we should have to consider or study about 4 main periodic properties of the elements. Right? First of all, I categorize those into those 4 groups. First one, atomic radii. Number 2, ionization energy. Number 3, electronegativity. number 4, electron gain energy. Right. These are the main 4 things what we have to learn one by one. So we'll take the first one, atomic radii. Atomic radii, mainly we have to learn it under 3 radii, right? So we'll take the first one under atomic radii, van der Waals radius. Okay, van der Waals radius. Then the second one, covalent radius, right? Covalent radius. Number 3, metallic radius. Right. We have to learn one by one about these radii. Right. First of all, according to our previous knowledge, what are the main factors that affect to the atomic radius? I think you can memorize, right? The size of the atom depending on what? Size of the atom depending on the attractions between the positive and the negative. That negative means, earlier I told, effective nuclear charge and the screening effect of the electrons, which are in the innermost energy levels. So if the innermost energy level electron number is greater value, then what will happen? Then the attraction between the outermost energy level and the nucleus is going to be reduced. In the other way, we can tell it, effective nuclear charge is going to be reduced. So the atomic radius can be increased accordingly. So we can discuss it that comparatively, we can discuss it like that with the periods and the groups. So beforehand, we'll discuss what is van der Waals radius. So I'll explain that. Think there's a molecule with the identical atoms. And then another molecule with the same identical atoms. When they are in the very stable form, right? Very stable, very close at hand, then the distance, we can measure the distance between these two, right? So measure the distance between 2 and divide it by 2. That is the van der Waals radius. Van der Waals radius, I will explain it again, that when the identical 2 atoms are combined and the same similar type of molecules are very close at hand, and they are at the very stable state, then the adjacent unbonded 2 atoms, right? You can identify these are not bonded with each other. Unbonded 2 atoms, right? Half the distance between the unbonded adjacent 2 atoms is the van der Waals radius. Okay, van der Waals radius. Then we come to the covalent radius. That in the covalent radius, always we are considering the molecule with the identical atoms and bonded singly with each other. Single bonding between these 2 atoms. Then the distance of the 2 nuclei divided by 2, that value is the covalent radius. Okay, this is the distance between these 2. It is divided by 2. Right, we'll label this as D1, this is D2, D1 and D2. Right? Okay, this is the covalent radius. This is the van der Waals radius. So if we compare these two, which one is greater? Van der Waals radius is greater because in that case these are very close at hand. These two atoms are very close at hand, but they are not combined with each other. But in this case, the covalent radius, we measure the half the distance from the two nuclei which are bond with each other with the single bond. So that is the most important part. Always if you compare this and this is greater than this. This means van der Waals radius. Van der Waals radius is greater than the covalent radius. Then we come to the third one, metallic radius. So let me erase this. I think you have heard that metallic bond in the metallic lattice. So very simply, if I explain the metallic lattice, right, if we take the piece of iron, right, that positive ions, Fe positive ions, Fe2 plus or Fe3 plus, and the released electrons are moving in the lattice. So the number of positivities and the number of negativities in the metallic lattice is same, but they are existing as the positive ions and the sea of electrons. So these are labeled as the delocalized electrons. What are they? Delocalized electrons. Delocalized electrons. These positive ions attached with the electrons which are in the sea of electron. We label this as sea of electrons. This is the special metallic lattice. So the positive ions always combines or make the static electric charges with the delocalized electron. That bond is the metallic bond. Then the metallic radius, we discuss it in details later, right? But only thing what you should know is the metallic radius. Metallic radius means the half the distance between the adjacent two ions in the metallic lattice. Adjacent two ions, right? The distance between the two nuclei, if we take the half from there, that is the metallic radius. So these are the three radii. I think I'll summarize it again. Covalent radius, two identical atoms are bonded singly with each other, and we take the half from the distance between two nuclei. That is the covalent radius. Then the van der Waals radius, the atoms which are unbonded but they are very close at hand when they are in their stable state. That we are taking the distance between two nuclei of the adjacent two atoms and divided by 2. That is the van der Waals radius. Then the metallic radius, which is in the metallic lattice, that always the metal are existing as ions, they are embedded in the sea of electrons, right? Sea of electrons which are delocalized electrons. So the two cations, adjacent two cations, nuclei, distance divided by 2, it is the metallic radius. This is the resource book details, right? Page number 32, van der Waals radius. Please try to make your own note about this stuff. Covalent radius and the comparison of covalent radius and the van der Waals radius and the metallic radius. Periodic trends in the atomic radii. periodic trends of atomic radii. Okay. Then in this stuff we have to discuss how the atomic radii increases or decreases or vary according to the period and the group, right? So we'll take the first one, down the group, right? So if we take the group 1, right, group 1 starting with lithium, then sodium, potassium, rubidium, cesium, francium, right, group 1 elements. So when going down the group, we can discuss how that atomic radii changes, right, increasing or decreasing. So according to your knowledge, previous knowledge, you know the lithium contain only 3 electrons. Then how many energy levels? 2 energy levels, right? Here 2 energy levels. Then here 3 energy levels, right? Here 4 energy levels. Here 5 energy levels, like that. So the number of energy levels are going to be increased when you are going down the group. Then what will happen? Now use the previous thing what I explained, right? So this nucleus is there with the protons and neutrons. Then the number of energy levels are getting increased. So when the number of energy levels are getting increased, the number of electrons in the outermost energy levels are also getting increased. Then what will happen? That electrons act as a shield or a screen to the outermost energy level. The outermost energy level, if we take the group 1 as an example, 1 electron, right? 1 electron. Then the innermost energy level electrons act as the screen. Therefore, the actual feeling of the positivity to the outermost electron is not that much because of that screening effect. Therefore, the effective nuclear charge is low, right? ZE, effective nuclear charge, actual feeling of the positivity to the outermost energy level is low because the number of electrons are increasing in the innermost energy levels, and as well outermost energy level has only 1 electron. Therefore, this one is low. According to that, when comparing to the size is bit larger, right? But when going down the group, it is increases, right? Increases the number of energy levels. Therefore, the screening effect increases. According to that, what happens? According to that, the size will increase, right? So, as a summary, we can tell when going down the group, the size of the atom increases or the atomic radii increases, right? Atomic radii increases down the group. That when you are explaining it, you have to explain it with the screening effect, right? Screening effect. Similarly, if we talk about the atomic radii along the period, when along the period, the number of energy levels kept as constant, right? Number of energy levels kept as a constant. But what happens there? Increasing the number of electrons in the outermost energy level. So, when we consider that, the screening effect for the whole period kept as a constant. But what is changing? The number of electrons in the outermost energy level changes. If it is increasing, what will happen? The attraction to the positivity or the nucleus is going to be increased. Therefore, the size is shrinking or size is decreasing. Then we can talk about that towards the, from left to right, from the period, atomic radius decreases. Atomic radius decreases across the period because screening effect remains as it is, but the attraction is getting increased from period to period because the number of electrons are getting increased, right? So down the group, atomic radii increases because which one is kept as a constant? Effective nuclear charge is kept as a constant, but the screening effect increases. According to that, the size will increase. So that is simple theory, right? So you can explain it like that. So now we see the diagram of that increasing of the atomic radii. Now the electron configuration of ions. So we'll take one example, sodium, right? 1s2, 2s2, 2p6, 3s1. So in the other way we can write it in the configuration of neon and 3s1. So when the sodium is releasing its outermost electron, what will be the electronic configuration after that removal of electron? So it reaches to the configuration of neon. So what does it mean? S2P6 octet is already filled. Then what you can tell about the size of that cation, right? Cation. So sodium atom has a certain size, right? Sodium, size of the sodium atom, we think the size of the sodium atom is like this. Then it has 3 energy levels, right? 1s2, 2s2, 2p6, 3s1, right? So after removal of that one electron from the outermost energy level, then what happens to the radii, right? It comes up to the neon's electronic configuration, 2s2, 2p6, 1s2, 2s2, 2p6. Then one energy level has already removed. Then what will happen? The size of that size of the ion is getting smaller than the sodium metallic ion. Therefore, always sodium plus ion, atomic radii of ionic radii of sodium is always lesser than the atomic radius of sodium. So similar case we can observe if you take chlorine. Chlorine 17, atomic number 17, 1s2, 2s2, 2p6, 3s2, 3p5. Right. Then when it is going to complete its octet, it should have to take one electron from outside. Then it reaches to 2p6. Right. Then how many protons in this chlorine? How many protons? 17 protons. But how many electrons? 18 electrons. Then what will happen? The nuclear charge, effective nuclear charge is going to be decreased because the number of electrons are greater than the number of protons. Therefore, the size will be bit larger than the atom radius of the chlorine atom. So, we can tell it when it is forming Cl minus, right? Cl minus ion, always ionic radius is greater than its normal atom. Comparison of the ionic radii of elements. We take examples, group 1, lithium to rubidium. Then you can see ionic radii of lithium is the smallest when comparing to the other elements of the same group. So similarly, all the groups, when going down the group, ionic radii also increases like the atomic radii. But if we consider the same case of the ions that are forming negatively charged ions, their ionic radii is greater than the atomic radii. So when we are from the parent atom, so we can take the comparison. Always the atomic radii of the parent atom is greater than the positive ion but lesser than the negative ion. So that is the theory. Okay, then we can talk about the isoelectronic series. So isoelectronic series means the elements which are belonging to the same period, sometimes they are removing electrons and gaining electrons and come up to the same group 8 element or the group 8 elements electronic configuration gained by that ions. Example, O2 minus, F minus, neon, sodium plus, magnesium 2 plus has total number of 10 electrons. In any isoelectronic series, the nuclear charge increases with increasing atomic number in the series. Because the number of electrons remain constant, ionic radius decrease with the increasing nuclear charge. Right? You can observe the figure 1.36 radii in the isoelectronic series. Whether they are isoelectronic, even the ionic radii differ accordingly. So you can understand that according to the number of protons in their nuclei. That also affect to the size of the nucleus, size of the atom or the ion. So when they are removing or when they are gaining electrons, their number of electrons are going to be differ than the number of protons. Therefore, the attraction is going to be increased or decreased accordingly. If the attraction increases, then it will be having low ionic radii than the parent atom. If the attraction is high, this is the example for the isoelectronic series, right? O2 minus, F minus, neon, sodium and magnesium. So neon can be kept as a comparing material and then compare these other things with that, because after formation of all these ions, all are having 10 electrons, right? Then O2 minus. O2 minus means it has 8 electrons and excessively it has taken 2 electrons. Therefore, the number of electrons are greater than the number of protons. According to that, the attraction between the outermost energy level and the nucleus can be reduced and the size of the cation increases. Similar manner for the F minus. Then we take the sodium plus. Then sodium has atomic number 11, then proton number is also 11, electrons 11. But sodium plus has already removed 1 electron. Therefore, it has 11 protons and 10 electrons. The attractive force has increased. Accordingly, the size of the positive ion decreases. So the radii of positive ion is smaller than the parent atom. On next day, we will discuss ionization energy, electronegativity, electron gain energy. We'll meet in next video.